welcome to our presentation. We are Doumith Engineering. My name is Matthew Duffy. My associates today are Yat Toss, Mark Doumith, and Doumith Swafford. Today we're going to give you our presentation about the Polk Street reconstruction. However, I'd like to start our presentation with a slight aside. Here at Doumith Engineering, we value safety paramount above everything else. And so it is our goal to start every meeting and presentation with a quick safety moment. I saw a smile. With the summer months coming up and school getting out, we need to all be reminded that there are going to be a bunch of new drivers on the road during the summer. It is a very, stop smiling at me, Jeff. It's a very good time for students to start their driver training or be practicing with their parents. These drivers are going to be more unattentive. They're going to be more likely to take risks, and it is on ourselves to manage our driving in a more careful and more safe way. Just a tip for your personal safety in your everyday lives. With that, I want to start our presentation. When we designed this presentation and we started this PowerPoint, we wanted to showcase what our design for Polk Street would be. But this is also our senior class presentation. And what this class was the single hardest class we've ever experienced in our school. We wanted to accurately convey the challenges that we faced and the struggles that we felt as a team, alongside giving you a glimpse of what we've designed for Polk Street. And so with that, I'm going to hand it over to my partner, Yas.
So we are presenting the design project on reconstructing Polk Street from Seminole to emancipation. It's about 12 stations. Polk Street is an 80-feet right-of-way with two traffic lanes, two parallel parking, also two sidewalk. But all of those is in really bad condition. They are the pavement is pounding. The power pole is like cracking, as we see the day we visit. And so with all of this, here the change we made, we come up with 3 traffic lanes with the shared turn lane in the middle, and also come up with bi-lane. This is the request from our client, and also the buffer zone, and also the green area. But to make sure that we have 2 feet for the amenity zone, that we can place the power pole and light.
And that 2-foot amenity zone still leaves about 5.5 feet of grass, so that if Yacht's dog, if his dog wants to, use the bathroom, maybe he has a chance to do that as well. So, for what we actually went out and designed, we had a lot of restrictions on our design, ADA requirements for ramps, drainage, requests from the client. We did our best, and the challenges we faced as a group to implement these designs the best we could, whether it be in putting in C1 inlets and having them match up with the current construction going on the cross streets, or just trying to match up our gradings from the street to our ADA requirements. So our issue was the same with many other groups, is that we didn't want to just throw our whole street up there so you guys couldn't read it. So we tried to scale it down. This is just part of our project. You can see we have our call-outs to our different inlets with their distances from the right-of-way, center line. It's a little difficult to read. I thought it'd be a little better. But we followed the IDM requirements, ensuring that no more than 2 inlets reach the manhole. Our group decided we did not want to renovate or remove the 24-inch reinforced brick concrete sewer that moves from San Emmanuel towards the highway. We chose instead to place a junction box there and do a cut tie-in. I know our professor recommended us not to touch that with a 10-foot pole, but unfortunately it is part of our project that we have to put this water somewhere. We hope that the junction box, along with a less steep grade of our trunk, would allow for us to accurately and safely convey water into the 24-inch pipe. Some of the things we did was we upgraded all the existing stormwater lines from the inlets to 24 inches, which then lead into a 30-inch that leads into a 48-inch trunk. We considered using a 3x4 box culvert, but based on the little extra area the 48-inch pipe gave us, we elected to go with that to better hold water and inline detention. This is just, again, it's our profile of that previous section. We have our water line, we have our inlets and our crosses. You can see in our water line we have a 12-inch with 2-inch extensions for connections, as well as our sanitary sewer, which is also 12 inches. Our connection for that is actually a 36-inch existing line on Bastrop, which is quite deep. So we had to install a 12-foot drop structure. Luckily enough, we had a lecture on that just a few weeks ago, explaining how those are used and how they're installed. So that would be, more details of those would be available in the plans. Here's a much closer view of what we tried to do with our utilities, how we connected to this existing 24-inch water line. On Hutchins Street, there is a proposed water line that connects with, if I remember the plans right, it's a butterfly valve, I think is what they called it, into the existing water line. So that water line is not being removed. We're going to connect our 12-inch into that. Again, most of the challenges we had here were just being thrust into a nomenclature we weren't familiar with, into specifications that we had never been exposed to. Anyone can go in a guy's class and grade a pipe, but when you actually have to go put that pipe in the ground and you have to move it around water vaults and other existing utilities, it gets a lot more difficult. Just another aspect here, you can see the junction box that we have for the 24-inch cut and connect to the existing flow line. More C1 storm inlets. That's pretty self-explanatory, I guess, at this point for me. I've looked at this for so long, but I'm going to hand it over to Dalton to get a bit about our cost estimates.
As previously stated from Matt and Yacht, our group wanted to reconstruct Polk Street, and the approximate total for the project was $4.1 million. With the cost of the bridge added in, it totaled out to $9 million. This cost was derived from the demolition plan right here, which is showing that we took out all the existing roads and sewers and pipelines. We also installed the storm drainage and various other things.
Okay, now let's get serious. Enough with all the infrastructure, that's gonna be underground. We were tasked to build a pedestrian bridge that was gonna take our pedestrians and bikers, yes, that's you, Chris, from one side of the highway to another. We looked into several designs. There were the trusses there, but we decided to go with something more aesthetic, something more appealing to the public. And that's essentially what our client asked for. So we went with a tight arch bridge. We went with 3 spans that were modeled in a way that would be able to accommodate all our pedestrians and our bikers from one side to the other. It was designed to be 25 feet wide, that it would cross the highway from one street to another, and it will accommodate 240 feet in the middle with 200 feet spans on each side. The spans, again, vary. Now, in this example, we took the 25-foot span in the middle, the 240-foot span in the middle. Its height was going to be 25 feet. It was designed in a way that we would use W24 by 68 structural steel, and it was going to be 10 sections, 24 feet each. The live loads, going through the structural stuff for a second, the live loads are 100 pounds per square foot, dead loads 100, and the wind loads were 50, which would total out at 300 pounds per foot, and it would be 55 feet above the highway. Now, as for the cross-section of our bridge, we took an approach that we are going to use cables to suspend the arch and the deck. It was going to be a bundle of 4 cables, 1 3/8 inch each. Now, we took a factor of safety into this. 2 cables will be able to hold the bridge, and we decided to go with 4 just to make sure if anything happens to a cable, that we would be able to accommodate that. Our deck is gonna be 8 inches, and it's gonna be reinforced concrete. For draining our bridge, I know we all love your drainage, so we looked into several options, and our main option was, unfortunately, a British solution called EnviroDeck drainage.
5 minutes.
And that is essentially those boxes you see here on the lower corners, and they are able to drain the water from the street, from the bridge all the way to the highway and street water systems. We decided to go with a C223 railing, and to light the bridge for night use, we used LED lighting. Now, to get people up onto the bridge, everyone was like, yeah, we're gonna use ramps, and it's great, and it's like 6 decks, and it looks awful. We took a different approach, and we used escalators. For our pedestrians, we used the Cone Transmaster 180 escalator. It is a custom-built escalator that we contacted the company, and they were able to accommodate such design. It's 20 feet high, it's 40 feet wide, and it works at 100 feet per minute, which is approximately 1,000 people an hour. And it has audible alarm systems, and it is 40 inches wide, so it can accommodate the fat people among us, myself included. So we needed to accommodate people with disabilities to be ADA compliant. We use the Severia Omega Incline platform. Again, that's another custom-built platform that is able to, any wheelchair is able to roll in. They will close the safety, whatever you want to call it, and then press the button and it'll take you up there. It goes at a speed of 12 feet per minute, and it just needs a 3 horsepower engine or motor. Over here, this is the cross section, this is the plan for the escalator and the lift. On the sides, over here, we have a lift for the bicycles. It's very simple. You just walk in your bike, and a clamp will hold your front wheel, and it will just essentially push your bicycle up there. In the middle is the lift for the ADA, and then the escalators on each side. This is the steel column and the street columns. They are textile compliant, reinforced concrete, 200 feet high. They are 5 feet wide, and they have a length of 25 feet, just as wide as the bridge. And the highway columns, again, textile compliant, 5 feet wide, 4 feet in diameter, and 25 feet wide at the streets, and 55 feet high on the highway. Now, to accommodate the foundations for that bridge, it is a huge structure, and we need to take into consideration the high moment that would be at the bridge base. So again, TxDOT compliant, everything is dictated through TxDOT. We use the factor of safety of 4, and we use 6 drill shafts, 80 feet deep, 4 feet wide, and reinforced concrete.
2 minutes.
Thank you. Done. Be nice.
In the back, I see 2.
I have a question about your escalator and your lift.
Yep.
Electric.
They are electric.
So what happens if you have no electricity? How can people get off of it?
If it happens in Houston once every 10 years that electricity goes out, there's a blackout, people using the escalators will simply use it as a stair if they really have to cross the bridge. And we just cannot accommodate people using wheelchairs in the inconvenient occurrence that there is a power outage and the lift will not work. Yeah. We can blame the mechanicals and electricals for that. Any other questions? Yes, sir.
I saw the demolition plan was on one slide, but it really didn't show limits. What streets are those, for example, and where do y'all plan on starting and stopping the demo? Maybe just start trying some estimation. How far y'all demoing?
Yes, you're talking about how far we go into the cross
This
streets?
seems to be the full limit of what you're showing.
Okay, yeah, that actually, I see how that would be confusing, but we cut the demolition plan off for the PowerPoint where it actually stopped in our plans, just for space considerations. That's
So is that that San Emmanuel and Hutchins?
Yeah, this would be San Emmanuel, and this would be Hutchins.
Okay, and kind of parlaying into this, did y'all do a TCP and did y'all look into traffic control or do construction sequencing?
That goes back to the challenges we faced as a team. We did get minor what's the word I'm looking for? Put it on line. We started, but we did not get to the same extent that other teams did. So we have a basic understanding of how we would do a two-way traffic control plan during our construction of close off one side of the street. We actually, back at our proposed cross-section, what we were planning on doing is we aligned our streets so that the center line is actually right in between our traffic lane and our turn lane. So we would construct the double lane first, side that has 2 lanes on it, and then we would go back and construct the bike lane in the second half. So that way we'd still have 2 lanes of open traffic, and then once the road was finished, we would convert the turn lane to an actual shared turn lane. That was our goal, was to not make that much of an impact into the actual project.
And then, since you're talking about the bike lane, maybe some of the other groups will talk about it as well, so I'm not trying to single it out.
That's okay.
How did you plan on integrating that bike plan with what you already saw happening across from Emancipation? So with folks on the east side of Emancipation, you're transitioning into that with the bike plan, and how you make that flow with your plan, what did you guys consider?
You're saying,
So there's-
where do we
you
connect
got
our
a
cycle
bike
track to the double bike lane that's divided?
Yeah, so you have a bike lane on the east side of Emancipation, that's
Yes.
only one side of the street, and you're transitioning that into what you're proposing here, or what you are not doing, just curious what you guys thought about.
So in the go by plans that EHRA provided, there was a plan to make Bastrop Street into more of a walkable promenade, I think is the word they used. We planned on creating a pedestrian island there to remove the left turn lane and actually do a slight shift of the street so we can align with Emancipation better as well. But we would use that pedestrian island as both a crossing for Bastrop and the dog park, as well as a crossing for the bike lane, where the bike lane would then split quadrilateral.
So that would be a different cross section?
That would be a different cross section, from a typical cross section, yes sir.
No more questions? Great.
No
one?
Yes sir.
Yeah, how did you guys size your mitigation detention?
Are you talking about the 48-inch or the junction box at the end?
Well, I assume the 48 inches where you're getting your mitigation point.
Yes, that's what we intended to use as our incline detention for.
How did you determine that's what you want?
We made an Excel spreadsheet. We tried to use HughStorm, but we could not make it work for us that well. So we ended up making our own Excel spreadsheet that has the IDM requirements for detention based on a 2-year and 100-year storm. And it was just kind of an iterative process of trying something out, kind of getting told we weren't doing enough, and then moving on up. And so we eventually came to, we needed an area, cross-sectional area that we needed, and we opted for the 48-inch. Any other questions? Perfect. Thank you so much.
Great.